Welcome to the second video in the series. This time we're joined by a lovely teaching assistant named Blümchen. She's maybe not too happy to be here. Let's let her go on. What do you think? Yeah. Okay, well, I guess she won't be joining us for the whole video. This is the second video in a two-part series where I, Jascha, will be conquering some Math A HL past paper questions. Now we'll do section B of paper 1. We're going to do one quite difficult question I picked out for you guys from 2023. In case you didn't watch the first video in this series, I do encourage you to go back and watch that first, just to get some more practice in. Alright, let's get right into it. So, we have got quite a lot of text, and as always, in the top right corner, you can see where I got the question from, and I'll be showing you all the sub-questions as we kind of go. So pause the video here, take a second to read through the question, try it yourself, and then we can attempt it together. Okay, we have got a little bit of a diagram right here with a bunch of information. So I think with questions like this, it's always just a good idea to really, when you are in an exam setting, take a deep breath and not freak out and be like, oh my god, I can't do any of this, this is way too hard, and it says sec and cosec down here, I don't know what any of those mean, oh my god, right? Just deep breath, trust me, we can do this question. Okay, so what are we looking at? We want, what is the question? I always think it's a good idea to first read the question and then read the text, and that's kind of the order I always do. We need to show that L is that. Okay, let's read the text and see if we can figure out what L is. L is the length AB in meters. Okay, so A is here, B is here. So the most important information right away is that we need to find this whole length. This right here will be length AB. Put a little magnitude like that. Okay, so that's what we need to find. We probably need to break this up into a shorter section first. So maybe let me just use my fancy technology here. And let's say we've got this section first, the screen section, AC, let's call that AC. And then we probably want to be adding, again, let's use this lovely purple right here. We want to be adding this section right here. That would be CB. Well, let's start with the purple section here, because now I've got that purple color. How can we figure that out? Well, we can just turn this into a right angle triangle. We all love right angle triangles. What do we know? This is a 90-degree angle. This right here must be the same as this length, right? So this must be 6 meters. And other than that, we don't know much. But what do we know? We know SOHCAHTOA, right? So, if in case you don't know SOHCAHTOA, I'll just write it out right here. SOHCAHTOA. We use this a lot for right angle triangles. In this case, it's going to be super useful. So basically what it tells us, let's see which one we want to use here. We have got the opposite, so the O, right? So this right here would be the O, and the hypotenuse. So we want to be using SO, because we've got O and H. So we know that sine alpha is the angle, so sine alpha will be the opposite, the 6 meters, divided by the hypotenuse. That would be the length CB. I see I didn't put the lines sloppy work here, Jascha. Okay. So we now know that we can isolate CB. We now know that from this, the length CB will be 6 times 1 over sine alpha. And what do you know? Sine alpha, if we look in your formula booklet right here, sine alpha will be cosec. So that'll be 6 cosec alpha. Okay, well, we've got this part of the equation, so hopefully if we now do the green bit, the length AC, we'll hopefully get the 304 sec A, but let's see. So now what do we have? We now have the adjacent. We have the adjacent, and look at this. This right angle is just a projection of the other triangle, so this angle right here, will be alpha. That will be alpha. Okay, so we've got the length here, that's 304, and we've got alpha, and we want the hypotenuse. So adjacent, hypotenuse, we need to use ka. Okay, so we need to use cosine now. So let me just write that over here. So we've got that cos alpha will be the adjacent, that will be 3 over 4 meters. That divided by, I'm going to write this a little bit funky now because we've got the fraction already there, divided by the length AC. Okay, and we do the same rearranging, so that we could find out that we have got that the length AC is 3 over 4 sec alpha, just using this formula now. Okay, well, we said before the length AB is length AC plus length CB. So finally, let's finish up this question right here. We can then say that the length L is then, it'll be AC plus, what do we call it? We called it CB. So we just insert what we found. That'll be 3 over 4 sec alpha plus 6 cosec alpha. Lovely stuff. First question, first 2 marks. Maybe a little bit, quite a lot of work for 2 marks, but if you know the SOHCAHTOA, shouldn't be too tricky. Okay, let's get into the meat of this. Now we need to differentiate it. So now we need to find dl d alpha. Well, to differentiate sec and cosec, we need to take a look in our formula booklet, and then we just kind of need to insert everything. So let's just remind ourselves what was L. L was 3 over 4. 3 over 4 was it sec or cosec? That was sec. Sec alpha plus 6 cosec alpha. Okay, differentiating that, we just use our rules. So dl the alpha, that must then be 3 over 4. What is sec differentiated? Then we take a look here. That would just be sec alpha tan alpha plus 6, and cosec differentiated. Aha, okay, so that'll be a negative. Maybe actually let's just turn this into a negative then. So negative 6 cosec alpha cotangent alpha. Cotangent is just 1 over tangent, right? Okay, now we need to show that when this is equal to 0, show that alpha equals arctan 2. Okay, I'll just change color here so that we don't get confused. And I'm now working on question II. Okay, so we now need to set this equal to 0. Well, if we set that equal to 0, then we can add the 6 cosec alpha cot alpha to the other side. So from that, we get that 3 over 4 sec alpha tan alpha equals 6 cosec alpha. Ugh, that was a weird alpha. Cosec alpha cotangent alpha. Okay, now some of you might go, oh my god, how do I ever solve this? Well, I think it's useful if we just turn all of this back into sines and cosines, because then you're going to see how this all clears up really, really nicely. I oftentimes get asked, how do I spot for things like that? I don't know, practice, I guess. It's always with, whenever you have a tangent and you need to solve things with a tangent, try rewriting that tangent into sine divided by cosine, and usually you'll get somewhere that is. Okay, so maybe actually I will multiply the 4 over and divide by 3 just so I get all the constants over on the same side as well. I'll do that in this step as well, just so you aren't confused. So sec, remind myself what was sec. Sec was, maybe if I go back to the formula booklet, 1 over cosine. Okay, so 1 over cos alpha. And then tan alpha is nothing but sine alpha divided by cosine alpha. Those two things are multiplied. Now I said before, I'm multiplying the 4 over, so 6 times 4, that would be 24. Divide by 3, that makes 8. Okay, cosec alpha, that was 1 over sine alpha. And then cotangent, well, cotangent is 1 over tangent, so cosine over sine. So this would be cos alpha divided by sine alpha. And now we just need to put all the cosines and sines on the same side. So if we do a little bit of simplifying real quick, we can see that these multiply together. So, and then I multiply all the sines over, and doing all that cross multiplication jazz gets me eventually sine cubed alpha divided by cos cubed alpha equals 8. Aha! Sine cubed alpha divided by cos cubed. Sine over cos, what was that, guys? That was tangent. So this is tan cubed alpha. And how do I get rid of a cubed? Well, I just take the cubic root of everything, and if I take the cubic root of both sides, finally I get that tan alpha is 2, And if I take the arctan on both sides to get rid of the tangent, arctan is the same as, so I'll just let me write that over here because I know this confuses some people. Arctan is the same thing as tan -1 of what's inside. So arctan alpha is that button on your calculator as well. So taking the arctan of both sides, that would then leave us with alpha equals arctan 2. Lovely, 5 marks, just like that. Awesome, let's keep the ball rolling, you guys. Let's keep it up. Okay, now let's try question C. This is where things might start getting a little bit silly, but we'll manage, we'll figure it all out. So let's have a look-see here. We need to now find the double derivative of L. So we already had dl, let me just write what dl d alpha was before. Let's have a quick look-see. So I think that was 3/4 sec alpha tan alpha minus 6 cosec alpha cot alpha. Okay, now I'm not gonna lie, guys, here. I think this is the probably most annoying question of this entire paper, maybe even. So you know what? Editing Jascha is gonna go and do some magic, and watch this. This is the magic of YouTube, you guys. As I snap my fingers, wow, okay, so as I snap my fingers, the derivative magically appears, and this cat did too. Very interesting, no? No? Wouldn't it be nice if that always worked like that? If you did some math and a cat just magically appeared? Oh well, okay, Amber, you may leave now. Okay, so, where were we? Oh, look at that, editing Jascha made a mistake. That should not be a plus, that's a multiplication right there, so if you were annoyed by that, if you got something else, that was just a little bit of a mistake. But yeah, this is genuinely the answer as it stands in the mark scheme. I actually had to double check because I just couldn't believe it as I was making the video. But yeah, so I guess in this paper they really didn't want any neat answers. Speaking of not wanting any neat answers, take a look at II, where we have to show that when alpha equals arctan, the double derivative is equal to this mess. Okay, let's have a look then. Well, if alpha equals arctan 2, what is tangent then? Well, tangent of alpha, well, that would be tangent of arctan 2. And, well, arctan, some of you guys maybe know arctan as, you know, tan to the power of -1 on your calculator, same thing. That just becomes 2. Okay, so tan alpha is 2. What is cot? What is cot alpha then? Well, cot alpha is nothing but 1/10, so that would just be 1/2, right? And now we, in our derivative, up here, in our beautiful derivative, what do we still have? We still have some sec, right? So we need to figure out what sec alpha is and cosec alpha. For that, we have these weird Pythagorean identities that I think no one has ever used before this question. So that's probably why they've written this question in the IV, so that they finally get to use these things in the data booklet. So we see that sec alpha will be the square root of 1 plus tan alpha squared. Tan alpha was 2, so 1 plus 2 squared, so that will just be root 5. And we then get that cosec alpha will be the square root of 1 plus 1/2 squared. In other words, that is just root 5/2. And now all that's left to do is to insert all of these numbers into our double derivative, and hopefully it equals 45/4 root 5. Let's see. So we got 3/4 sec alpha, that was root 5, times tan squared alpha, so times 4, right? So squared, plus sec alpha cubed. Sec was root 5, so root 5 cubed. And then we say plus 6 cosec alpha. Oh my goodness, it just keeps going, doesn't it? 6 cosec alpha, that was root 5/2. And cot, that was 1/2, so 1/2 squared. Plus, oh, that 6 was also one too many. Editing Jascha was sloppy then. Plus cosec cubed, so that would be 1/2 cubed. Okay, now I'm not gonna lie, guys, this is gonna be a whole bunch of rearranging, and it would simply take too much time in this video. So I'll just simply tell you guys that this is correct, and this will equal 45 over 4 root 5, though I do encourage you to actually try and solve this, see if you can actually get this be equal to the other side here, because I think that would be really, really good practice. Oh, of course, I saw the little mistake to correct here. That is, of course, root 5 divided by 2. Now, I just want to leave you guys with a quick hint before we move on to the next exercise. To try and solve this, try and put it all on the denominator 4, and then it all simplifies out eventually. Okay, let's take a look at the next question right here. Now, this exercise deals with minimums, and minimums happen when the double, so of course the first derivative needs to be 0, then we are either at a minimum or maximum, and then when the double derivative is positive, then it's a happy smiley, right? So let me just write that here on the side, so f double dash. Right, when we have f double dash, if it is positive, then that means we have a happy smiley, so that would be a minimum, right? And if it's negative, then we get a sad smiley, so a sad smiley, happy smiley, sad smiley, and the sad smiley has a maximum, the happy smiley has a minimum. Okay, so what we showed was that we can say that when alpha equals arctan of 2, we know that the alpha is 0, which makes it either a minimum or maximum, and we know that the double derivative is positive. That was that weird 45 whatever value, right, from before. What was that? 45 over 4 root 5. That is definitely a positive value. That was positive, so when you have the first derivative is a minimum, the second derivative is positive, then we could say hence alpha equals arctan 2 is a minimum. Okay. Now we need to determine this minimum value of L. Well, then we just need to plug that number into our original equation. So let me just quickly write all of that out. Ta-da, there it is, just taken from the previous questions. So L was 304 sec plus 6 cosec. That was the very first exercise, you guys. And we know that when alpha was arctan, we know that sec alpha, in that case, sec alpha, we defined that actually in the earlier question, you guys, that was root 5, and cosec was root 5 over 2, right? So this would be 3 over 4 root 5 plus 6 root 5 over 2. And then we get to do some lovely simplification here. So that would be 3 over 4, let's put that together, 3 over 4 root 5, plus 3 root 5, I can write that as 12 over 4 root 5, and then I get that to be 15, oh that was a 3, it should be a 5, 15 root 5 over 4. Okay, lovely. Let's take a look at the last exercise then. And for this last exercise, we have some more text. 2 people need to carry this pole, a pole of length 11.25 from the passageway into the room. It must be carried horizontally. Determine whether this is possible, giving a reason for your answer. Okay, guys, so for it to be possible, right, this pole needs to fit through. I don't know why they're carrying it horizontally, by the way. They could just tilt it. But hey, this is a simple world. Otherwise, we'd have to do 3D stuff. That'd be even more complicated. So thankfully, they are carrying it horizontally. We need to find the shortest distance, right? So imagine, I don't know, that would probably be somewhere right here. You know, that minimum length, right? And we defined that already. That was our answer from before. So basically, we need to figure out, the question is, in other words, is 11.25 bigger or less than? So is that bigger than, what was that? That was 15 root 5 over 4. Okay, this is a weird question for paper 1. Paper 2, this would be super easy, just check with your calculator, right? But for paper 1, what do we have to do? Well, immediately I see, it'd be useful if they were both on, you know, divided by 4. And I can see 0.25, my alarm bells are ringing immediately, there's something going on there. So actually, 11.25, what happens if I multiply that by 4 divided by 4. So if I just multiply by that, well, then I get 45, then I get that, let me just rewrite this a little bit, so then I get that 11.25, that is nothing but 45 divided by 4. Okay, now we're down to, is 45 bigger than 15 root 5? Well, actually 1545, I can see a pattern here. I can see that that is 15 times what? 15 times 3 over 4. Okay, and now the final question then is 3 bigger than root 5? Well, 3 is the square root of 9, and the square root of 9 obviously is bigger than root 5. So therefore it is not possible. It is not possible. Why is it not possible? Well, we say that 11.25, we just showed that 11.25 is bigger than this smallest line, right? The smallest possible line. All right, well, I hope that that cleared up some confusion for you guys in calculus. Hopefully this was a little bit helpful. If it was, please leave a like and let me know if you'd like to see more videos like this. Also, please let me know if there's any subjects you struggle with in general that you would like some guidance on. Maybe statistics, probability. Let me know. Write down in the comments below. Leave a like and share with your friends. Now, since this is a Lanterna video, I would of course be remiss without mentioning that we have a team of amazing tutors. So if you want some last minute help before your exams, or if you're watching this in the future and you just want some support throughout the IB, learn some more stuff about calculus or math in general, or any other subject, history, politics, we've got it all. Feel free to shoot us a message, have someone like me or any of these other lovely colleagues help you out. We'd love to be there for you, and see you in the next video, guys. Take care.